Welcome to the session. I am Dr. S. Anusha Kakeni, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to see about the energy sources. What are the energy sources and what are the types of energy sources, whether it is renewable, solid fuels, liquid fuels, non-renewable sources, and the analysis of these sources, analysis of the core material, and what are the types like proximate, ultimate analysis of this whole and its significance in detail. So the fuel is a substance, chemical substance which on combustion produces heat, large amount of heat and energy. So the produced heat is used for both domestic and industrial purposes. So the fuels contain generally hydrocarbons. Hydrocarbons is nothing but it's a combination of hydrogen, carbon and oxygen as main constituents, and also even in trace amounts of sulfur and nitrogen are present in as contaminants. So the sulfur and nitrogen present in very trace amounts as the contaminants. The constitution of these fuels are carbon and hydrogen and oxygen as main constituents. So the combustion. What is combustion? Combustion is a process where any substance burns completely. So the substance which we took was burnt completely in the presence of oxygen. That process is called the combustion. So on combustion of any product or any substance, large amount of heat will be released. So the fuel in the presence of oxygen. So any substance burned or burnt in the presence of oxygen. So this process is called combustion. So by the process of the conversion of any substance or burning of any substance, it releases heat. And heat matter plus combustible products and non-combustible products. So on the process of this combustion in the presence of oxygen, it results in this heat and combustible and non-combustible products or matters. So the classification of fuels. Generally, these fuels are divided into two types based on their occurrence and the state of aggregation. So the based on the occurrence, first we will see the left hand side. So the based on occurrence or preparation, there are two types. One is natural or primary fuels or artificial or secondary fuels. Under these natural and primary fuels, we can see the coal which are formed naturally due to the heat and pressure in the earth's surface. So the plant materials or animal debris undergo heat and pressure under the continuous closed environment. They are converted into the fuels. So the coming to the state of aggregation, there are three types again. So the right hand side state of aggregation, solid fuels, liquid fuels and gaseous fuels. So this category is based on the first is occurrence and the second is the state of aggregation. So based on the physical property. So whether it is a solid form, liquid form or gaseous form, these fuels are again divided into three types: solid, liquid and gaseous fuels. So we are going to see what are natural or primary fuels. These are found in nature such as wood, peat, coal, petroleum and natural gas. So these are found in nature naturally. And artificial or secondary fuels. These are prepared artificially from the primary fuels. So the main substance is the primary fuels, means natural origin. From that, these artificial or secondary fuels are prepared. Example: charcoal, coke, kerosene, diesel, petrol, coal gas, oil gas, producer gas and blast furnace gas. So here in the secondary fuels, the main product or the starting product or the first product is the primary fuels or natural fuels. So based on this, this is like crude material. it undergoes the extraction process. Further process will go on for the crude extracts. Then it will be refined. So the kerosene, petrol and diesel what we are using is all formed from natural or primary fuels. It acts as a source. It acts as a source to get these secondary or artificial fuels. So the next type of fuels. So in natural or primary fuel, wood, peat, lignite, dung, bituminous coal and anthracite coal. So these are the types in coal we are going to see in detail in the next slides. So this and the coming to these are the natural fuels, whereas in solid form. So again these natural and secondary also divided into three types like solid, liquid and gaseous based on their physical property. Now we are going to see the solid natural fuel. So these solid natural fuels are wood, peat, lignite, anthracite coal and bituminous coal. Comes under the solid category of natural fuels, whereas charcoal and coke comes under the category of solids in secondary or artificial fuels. Whereas coming to liquid, the crude oil. So the crude oil is natural or primary fuel which exists generally in liquid form, and the petrol, diesel and various other fractions of petroleum comes under the artificial or secondary fuels. The next is gaseous fuel, natural gas, which is a methane. Methane is produced under anaerobic condition, also called as biogas. And coal gas, oil gas and biogas, water gas, etc. come under the artificial or secondary level. So wood, coal comes under the solid, whereas gasoline, diesel, ethanol is an alcohol and comes under the liquid category, and propane, natural gas comes under this natural and secondary or artificial fuels. Here propane is artificial, whereas natural gas is natural or primary. This is secondary. Same thing here also. These are secondary fuels. These are natural fuels. Where in the solids category, charcoal and coke. So the same coal undergoes some treatment, some chemical treatment, they are converted into charcoal and coke. Then as we know, these natural and the primary fuels acts as a source on further treatment and further filtration. It is artificial or secondary fuels. So what we know what are fuels now. So what are the characteristics of good fuels? So it should have some high calorific value. So the calorific value means the burning capacity of the substance should be high, and moderate ignition temperature. And so for the starting of ignition means when we are going to start the burning process, it should catch easily and it should ignite easily. So it should have some moderate ignition temperature. Then the low moisture content. So once if the substance is having more water, it will take lot of time to ignite. So to avoid this, to avoid the time and fuel, we need to see the low moisture content fuel. We have to select in such a way it should be moisture free. And low non-combustible matter. As we know, when the substance is undergoes combustion process, it is heat plus combustible material and non-combustible material. So once heated, this process is called combustion. So under this process of combustion, it should be low non-combustible material and moderate with velocity of combustion, and the reaction or the heating process should be the moderate. So the velocity of the reaction should be moderate, not too low, not too high. So if the velocity is moderate, the reaction or it is high combustion value and high reheating temperature. The less toxic combustible gases. So under the process of burning or the combustion process, if the product is high toxic gases, then this is not a good character or this is not desirable, because it should not emit the poisonous or toxic gases. A good fuel should be readily available in bulk at low cost. So it should be available at low cost. So the cost and the quantity, the availability. This also plays a role in the characteristic of the good fuels. Handling and transport of fuel should be easy. So this is the one of the characteristic, like to transport from one place to another place, the handling and this transport of the fuel should be easy and low cost and highly calorific value with ignition temperature of moderate and moderate velocity reaction followed by low moisture content, no toxic gas release and non-combustible product yield should be low. So these are all the characteristics of a good fuel. So these are the characteristic properties of solid, liquid and gaseous fuels. Here coming to the solid fuels, coal. So the coal is cheap as it is available easily and easy to store and towards hazard risk. So towards higher it will comparatively less and combustion rate is a slow process and combustion control. So which can be controlled by us. So first we will see the solid, liquid and gaseous fuels here. Then we will move on to the another slide. So the example of liquid fuels is crude oil. This is a natural or primary fuel. Compared to coal, it is costlier. Compared to the coal solid fuel, it is bit costlier and closed containers should be used for storing because it is a crude oil. So oil liquid means we have to use the closed containers and the combustion rate is fast compared to the coal and cannot be controlled or stopped when necessary. So it is not in our hands. So the control rate of these reactions cannot be stopped. Coming to the gaseous fuel, primary or natural fuel, coal gas, it is costly compared to both solid and liquid fuels. Then storage space required is huge and should be leak proof. Being a gas, it should be leak proof and we need the huge storage space. Very high since these fuels are highly inflammable. The risk is very high because these gases are highly inflammable. It catches the fire easily. Very rapid and efficient combustion rate and controlled by regulating the supply of air. So by the supply of air, we can control the combustion rate of this coal gas or natural gaseous fuels. Coming to the handling, next solid fuels, liquid fuels and gaseous fuels, handling, ash, smoke, calorific value and combustion rate and heat efficiency of these fuels we will compare here. So here high since labor required in the storage and transport. Being a solid, it requires more labor. So to transport we require more labor and for the storage purpose also we require more labor. And liquid fuels, it is low since the fuel can be transported through pipes. So being liquid, this transportation can be happen through the pipes. And gaseous, so this is also low because this gas also can be transported through the pipelines and can be attached to the transport vehicles. The pipelines can transfer easily. So compared to this solid, the liquid and gaseous transport is easier. Ash is produced and its disposal also causes problems. In solid fuels, on combustion process, it results in the more amount of ash. So once this ash formed, the disposal of this ash causes a problem. Where in liquid fuels, there is no problem of ash and for gaseous, same, no problem of ash. So here smoke, produce smoke invariably. So on the combustion of solids like coal, it gives the enormous amount of smoke. So it causes the environmental pollution. Whereas in liquid fuels, it's clean but liquids associated with some carbon and aromatic fuels that produce smoke. Compared to solid, it is very less. Whereas in gaseous fuels, the smoke is not produced. Calorific value. So coming to the calorific value, as we know, to being a good fuel, it should have high calorific value. Then here the solid fuels like coal, it gives least calorific value and compared to solid, it have high calorific value in liquid fuels and very highest in gaseous fuels. So the combustion rate. So the combustion rate, so it should be moderate and combustion rate should be at moderate. So it is a slow process, whereas in liquid fuels it is fast process, whereas in gaseous fuels it was very rapid and efficient. Coming to the heat efficiency rate of all these three fuels, it is very least in solids and high in liquid fuels, whereas highest efficiency was observed in gaseous fuels. So we are going to discuss more about the solid fuel, which is one of the abundant available source, which is coal. The best example of the solid is coal, and we are going to see how coal is formed. It is a process of conversion of peat to coal. So it undergoes some conversion rates, and it undergoes some conversion like peat to lignite, then bituminous coal, semi-bituminous coal, and the final formation is anthracite coal. So the main solid fuels are wood, peat, lignite, coal, and charcoal. So these are the main solid fuels. So one of the solid fuel we are going to see in detail the coal, about the coal. Coal is a rock that can be burnt, and coal is an energy source. It is a sedimentary rock and energy mineral. Legally, it is legally a mineral, but scientifically a rock. Coal is a fossil fuel because it is derived from fossil plants. This coal is formed from the debris of animal and plant materials under high temperature and pressure continuously in the earth's crust. It is converted into coal. It is mainly of carbon, hydrogen and oxygen and some trace amounts of sulfates and nitrates. In contrast, oil is a liquid hydrocarbon and natural gas is a gaseous hydrocarbon. So whether it may be a solid, liquid or gaseous, it is a hydrocarbon. So the chemical composition of the coal or the fuel is a hydrocarbon. Whether it may exist in solid form like coal or peat or wood, if it exists in liquid form like crude oil, or it exists in gaseous form like natural gas or coal gas, the hydrocarbon is the constituent of all these fuels. Coal and peat comes from the part of the carbon cycle. First, the coal is a fossil fuel, occurs in layers of earth crust. From where we are going to get coal? From the earth crust. It occurs as a fossil fuel formed by the decay of plant materials and accumulated millions of years ago and further altered by the action of heat and pressure inside the earth layers. Coal is formed from the physical and chemical reaction of the peat. So the peat is, what is peat? Then the peat is a plant materials that accumulated in wetlands which break down through the process of peatification. So the peat will break down. That process is called peatification. If peats are buried, then the peats are altered into different ranks of coal. So there are different ranks in coal category based on the presence of carbon in their structure or the content of the carbon. They are ranks in the coals. So that process is called coalification. So first, the process of conversion of wood to coal is this. Wood will be converted into peat, peat again lignite, then bituminous coal, then the final is the anthracite coal. So this is the peat. What is peat? It is a brown, fibrous, jelly-like mass. So this is nothing but the plant material in wetlands of earth crust. So lignite. They converted into lignites after a long period, like millions of years ago. These peats in the earth crust are converted into lignites. What are lignites? They are soft, brown colored and lowest rank coals. So the coal content means the carbon content in the lignite will be less. Compared to the lignite, the peat will have very less carbon content. So on increasing from peat to anthracite, the carbon content will got concentrated, and the coal means the more carbon content will be there in the anthracite coals. So what are bituminous coals? These are pitch black to grey coals. It is anthracite. It is a high class of highest rank coal. Around 60 to 70% of carbon will be present in this anthracite. So once the more carbon content, the more calorific value. So the more calorific value means which is a good characteristic and which burnt easily and which gives a reaction very close. The reaction will be high. The speed of reaction will be high, and the more carbon content means more combustion, high calorific value. So from peak to here the combustion value, this calorific value increases. From peat to anthracite, carbon content increases, calorific value increases, the rank increases. This rank of coals. So this rank of coals is due to the presence of the carbon content in the coals. So this is the lignite. Burial pressure, heat and time plays a crucial role in the conversion of peat to anthracite. This is a brown lignite and subbituminous and bituminous. The final one is anthracite coal. So fuel. This is what the percentage of carbon. Why wood is having only 50% of carbon, and the calorific value is 4000 to 4500, and it is used as a domestic fuel. Whereas the wood is converted into peat. Peat is having 550 to 60 of percentage of carbon. This is carbon percentage. So in 100%, the main constituent is 50 to 60% of carbon, and the calorific value is 4125 to 5400 kilocalorie per kg. So the used efficiency of high rank coal is prevailing. So the lack of these coals makes the use of this peat in the industries. Coming to the next category, lignite. This is a brown color moss which having 60 to 70% of carbon content percentage. Then it gives a calorific value of 6500 to 7100. It is used in thermal power plants for steam generation. This lignite is used specifically in thermal power plants. Whereas the bituminous coal or semi-bituminous coals contains 80 to 90% of carbon, means 80 to 90% of carbon is present in 100% of coal. So only 10% of in like contaminants or gases or minerals will be present in very less amounts. So the calorific value will be high, around 8000 to 8500. This is used in making coal gas and metallurgical coal. Metallurgical coke is used. This bituminous coal is used in the manufacturing process of coal gas and metallurgical coke. Coming to the last category and the best coal, anthracite. This is having 90 to 98% of carbon in their coals. Then the calorific value is 8650 to 8700 kilocalorie per kg. It is used in households and also for steam generation or steam raising in industries. So the analysis of coals. We know the brief outline of the coals. So the coals are the hydrocarbon compounds. So the more it depends upon the ranking of the coals depends upon the percentage of carbons present in the coals, and the calorific value also depends upon the percentage of carbon present in those coals. So how we can know? How we can know the percentage of carbon in these coals? So for this, the analysis is the main important thing. So the coals are tested prior to be used. Before using these coals are analyzed and tested. Some markets generally they require some quality characteristics before uses in the industry or in thermal power plants. So the environmental regulation also require knowledge of this coal's quality. Some products also require analysis of physical characteristics of coals in handling and processing treatments. So there are some standard tests which were developed by American Society of Testing and Materials. So they set some standardized procedures for analysis of these coals. So they have some procedure or they have some protocol to handling and procedures for sample preparation as well as the analysis of these coals. So they will give the ranking based on their analysis results. So they certify this coal as they commonly give the certificate like this coal contain this much of carbon, impurities, ash, volatile matter. So this ASTM means American Society for Testing and Materials is these follow a standardized procedure for sample preparation. So generally the common coal analysis include ultimate and proximate analysis. Means proximate means nothing but a qualitative analysis. So why the analysis of the coal should be there? Because it helps in its ranking. So it helps in classification and the quality of the coal. And elemental analysis, and based on the results we can use in the industries. For this industrial application, this analysis has to be done. The assessment of the quality of coal is carried out by the two types of analysis. One is proximate and another is ultimate analysis. Proximate is the qualitative type of analysis. So in this analysis, we indirectly determine the carbon content in the coals. So it is a quantitative analysis of the following parameters like moisture content, volatile matter and the ash content and fixed carbon present in the coal. So by this proximate analysis, we are going to find out all these four contents like moisture, volatile, ash and fixed carbon present in the coals. So we are going to see how we are going to analyze the moisture content in the coal. So this is the moisture this is the raw material, raw coal. This is the moisture content, volatile matter, then fixed carbon. So this is the flow of analysis. As we know, we are going to see these four moisture, volatile, ash and fixed carbon. So this is the brief. So first 1 gram of finely powdered air-dried coal sample is weighed in a crucible. These are the quartz crucibles. So they can they can tolerate high temperatures about 600 degrees centigrade. So these are silica crucible. If it is more than 600, we will use quartz crucible. This is silica crucible. So for below 400 temperature, we will use this silica, and more than 600, we will use this quartz crucibles. This is desiccator. It is filled with silica. Silica gel is filled inside the desiccators. So about 1 gram of finely powdered air-dried coal sample. So first what we have to do, 1 gram finely powdered and air-dried sample of coal has to be taken inside this crucible. This is the crucible. The crucible is placed inside the hot air oven and the temperature is maintained around 105 to 110 degrees centigrade for 1 hour. The crucible is allowed to remain in oven for 1 hour and taken out and cooled in the desiccator. So once this crucible has to be kept in a oven for 1 hour and maintained 105 to 110 degrees centigrade. Once this temperature was maintained for 1 hour, then this has to be kept in the desiccator. So what happens in the desiccator? The moisture present in the a moisture present in the crucible, it acts as a moisture-free medium and cools the coal without the reaction with moisture. So generally the main purpose of the desiccators is it maintains the moisture-free environment. If moisture is there, the silica gel or the chemical compound which we are using in the desiccator can absorb the moisture and makes the crucible, the coal present in the crucible will be moisture-free. So the loss in weight is reported as moisture. So once cooled in the desiccator, then the crucible has to be weighed. Crucible plus coal has to be weighed. So the percentage of moisture is generally calculated in loss in weight. So suppose if we took W1 at the time of this one weighing, so first freshly fine grinded and air dried sample, then W1 minus W2 is the loss in weight. So the weight of coal taken into 100. So first initial W1 into the 100 gives the percentage of moisture present in coal. So once what happens here, once it was kept in hot air oven, generally the water have temperature, boiling temperature of 100. So once if the beyond the 100 the water got evaporated. It's just simple and normal logic. So here moisture content, moisture is nothing but the absorption of coal with hydrogen or this water molecules. So once it was maintained at 105 to 110 degrees centigrade, the water absorbed by the coal got evaporated. So it is moisture free. Now we are going to see the loss in weight. So the moisture gone means the weight of the coal reduced. So the reduced weight, loss in weight divided by weight of the coal taken into 100 gives the percentage of moisture. Not only for coal, any chemical, the moisture percentage can be determined in this way. Next approximate analysis is volatile matter. Here, the dried sample is taken in a crucible, then covered with lid and placed in an electric furnace. Generally, these furnaces will be used beyond 600. Like for maintaining 400, 600 and 900 degrees centigrade, these furnaces are used. They have a layer of, this is a glass wool. So the backside that some heating mantle will be there. It maintains high temperature that was insulated fully with the glass wool. So this is maintained at 925 plus or minus 20 degrees centigrade. It's around 950 degrees centigrade. The volatile matter we are going to find out. Then it was maintained, the crucible is taken out of the oven after 7 minutes of heating. So we have to heat it for 7 minutes. So this is 950 degrees centigrade. The volatile matter, which is volatile in nature, it got evaporated. This is a dried coal sample we are taking here. Then it was maintained at 950 degrees centigrade for 7 minutes in furnace, electric furnace. Then the resultant is volatile matter free coal. The loss in weight, then the crucible is cooled first in air, the same thing, desiccators, then inside the desiccator and weighed again. So the loss in weight is reported as volatile matter on percentage basis. Same thing, loss in weight, then weight of coal here. This is suppose S1, then S1, the loss in weight, S1 minus S2 into 100 gives the, so S1 is the before weight and S2 is after weight. So the loss in weight is written here, then divided by weight of the coal taken, that is S1 at the in the sample, and into 100 gives the percentage of volatile matter present in the coal. Next is ash. The residual coal sample then taken in a crucible and heated without lid in a muffle furnace. Here for the first volatile matter and moisture content, we have to close the sample with the lid, whereas in here we no need to close the lid. We have to heat it without a lid in a muffle furnace at 700 plus or minus 50. So around 700 degrees centigrade for half an hour. So for 30 minutes we have to heat the coal sample. Then once the half an hour completed, the crucible is taken out and cooled first in the desiccator and weighed. Heating, cooling and weighing are repeated till a constant weight is obtained. The residues reported as ash on percentage basis. So the weight of ash left in the crucible divided by, so we have to repeat the procedure like heating of the sample at 750 degrees or 700 degrees centigrade for 30 minutes, cooling, then weighing. Again heating the sample for 30 minutes, cooling, weighing. So once here weighing, again same. The repetition of this process has to be done until there is no reduction in weight of the sample. Means the whole coal sample is converted into the ash. So there is no further ash formation in that sample. So that gives the final weight of the ash. So after this process, the final ash content present in the crucible, this weight is taken. Suppose this is X. So the X is taken. Then weight of coal taken is here. The weight. First thing is before heating the sample, we have to take in coal sample, right? Suppose that is Y. Then it is Y into 100. This gives the ash content present in the coal sample. Next, the fixed carbon. So the percentage of fixed carbon is equal to 100 minus the percentage of all the three analyses which we done earlier, which is moisture, volatile and ash. Suppose this is A and B and C. So the percentage of all this by subtracting the moisture, volatile and carbon content gives the percentage of fixed carbon present in the coal sample. So what is the significance of proximate analysis? Why we are doing this analysis? What is the importance of this proximate analysis? So this provides a valuable information in assessing the quality and ranking of the coal. So based on the quality and ranking, we can use it accordingly in industries and thermal power plants. So the application varies based on the quality of the coal. So moisture is a coal evaporates during the burning of coal and takes some of the liberated heat in the form of latent heat of evaporation. So without analysis, if we use the coal directly, the moisture absorbed by the coal takes lot of heat and latent of a heat of evaporation will be more. Therefore, the moisture lowers the effective calorific value. Because of the water present in the coal, it reduces the calorific value of the coal. Moreover, it quenches the fire in the furnace. Hence, lesser the moisture content, the better is the coal performance as a fuel. However, the presence of moisture up to 10% produces a more uniform fuel bed and less of fly ash. So up to 10% will be considered and it gives a uniform fuel bed and less of fly ash. Volatile matter. What is the role in volatile matter? A high volatile matter contains high proportion of fuel with distill over a gas or vapor. So generally volatile means which are converting easily to solid to liquid forms. So the volatile matter means in the coal, the gas or vapor forms present in the coal causes the volatile matter. So when it was heated, the volatile matter completely convert into gaseous form, then it evaporates easily. A large proportion of which escapes unburnt. So high volatile content of the coal is undesirable characteristic of the coal. As high volatile containing coal burns with a long flame, high smoke emission and low calorific value. These are undesirable and the calorific value should be high and without the temperature and the velocity of the reaction should be moderate and flame should be moderate and it should produce less smoke or no smoke also acceptable. Hence, lesser the volatile matter, better is the performance of the coal and the better is the quality of the coal and better the rank of the coal. Ash. The ash is a useless, non-combustible material which reduces the calorific value of the coal. So moreover, ash causes the hindrance of the flow of heat and air, thereby lowering the temperature in the reaction in the furnace or in the reaction in industries. In turn causes the obstruction to air supply, thereby burning the coal becomes irregular. The lower the ash content, better the quality and ranking of the coal. The presence of ash also increases the transporting, handling and storage cost. It also involves additional cost in ash disposal. So once the coal is burnt, the formed ash causes a big headache and causes a problematic situation because where to dispose this ash formed. So the presence of ash also causes early wear and means early damage of furnace walls and burning of apparatus easily. Then the next thing is fixed carbon. So what is fixed carbon? 100 minus percentage of volatile matter, moisture content, volatile matter, plus ash gives the fixed carbon. So what happens with fixed carbon? The higher the percentage of fixed carbon, greater its calorific value. So it depends indirectly on all these three. So if ash, volatile matter and moisture content is more, suppose it all constitutes a 20%, so 100 minus 20 is 80. If all these three constitute 50%, then 100 minus 50 is 50. So the fixed carbon depends upon all these three: moisture, volatile and ash content of the coal. So the greater the percentage of fixed carbon, smaller is the percentage of volatile matter. So it's like indirectly proportional. So the percentage of fixed carbon helps in designing the furnace and shape of the firebox because it is the fixed carbon that burns in a solid state. Thank you. This is all about the proximate analysis of the coal, what are the good characteristics of the coal to use in industries and thermal power plants. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.